Hello children, exercise 13.1, first question. Evaluate the following limits. Limit x tends to 3, x plus 3, which is equal to, here x tends to 3, so the value will 3 plus 3, which is equal to 6. Then limit x tends to pi, x minus 22 by 7, which is our second question. So x tends to pi, so it will change to pi minus 22 by 7. And the third one is limit r tends to 1 pi r square. So in the place of r we have to apply the limit. So pi into 1 square, which is pi. Then the fourth one is limit x tends to 4, 4x plus 3 by x minus 2. So 4 into 4 plus 3 by x minus 2, that is 4 minus 2. 16 plus 3, 19, 4 minus 2, 2. So 19 by 2. Fifth question, limit x tends to minus 1, x power 10 plus x power 5 plus 1 by x minus 1. Here x tends to minus 1. So x, we change it as minus 1 power 10 plus minus 1 power 5 plus 1 by minus 1 minus 1. Which is equal to 1 minus 1, 0, 0 plus 1 is 1, which is equal to minus 1 by 2. Then sixth question is limit x tends to 0, x plus 1 whole power 5 minus 1 by x. Here limit x tends to 0. So when you change this as 0 plus 1 whole power 5, that is 1 power 5 is 1. 1 minus 1, 0 by 0. So which is in the form of 0 by 0 form. So I am taking x plus 1 as y, so that y tends to 1 as x tends to 0. So this limit will change to limit y tends to 1, y power 5 minus 1 by y minus 1. I am writing 1 as 1 power 5 so that I can use the result limit x tends to a, x power n minus a power n by x minus a, which is equal to na to the power of n minus 1. So applying this result, I can write this as na to the power of n minus 1. Here n is 5. So 5 and a is 1, n minus 1, 5 minus 1 is 4, which is equal to 5. Seventh question, limit x tends to 2, 3x square minus x minus 10 by x square minus 4. At x equal to 2, when we substitute this, we get 12 minus 2 minus 10 by 4 minus 4, which is in the form of 0 by 0. So I am changing this limit as just factorizing the numerator and using the identity in the denominator. So factorizing the numerator, 3x square minus x minus 10. So the product is minus 30. Sum is minus 1. Minus 6 into 5. So minus 6 plus 5 is minus 1. Minus 6 into 5 is minus 30. So I am changing 3x square minus x minus 10 as 3x square minus 6x plus 5x minus 10 equal to 0. 3 into x taking common, x minus 2 plus x minus 2, 5 into x minus 2, which is equal to 0. So I'll get 3x plus 5 into x minus 2, which are the factors of this quadratic equation. So I'm changing the limit as 3x plus 5 into x minus 2. Here using the identity a square minus b square. Here b is 2 square, a square minus b square, which is a plus b into a minus b. That is x minus 2 into x plus 2. Cancelling x minus 2. Then x equal to 2, we get 6 plus 5 by 2 plus 2, which is equal to 11 by 4. So the value of the function is 11 by 4. Eighth question is, limit x tends to 3, x power 4 minus 81 by 2x square minus 5x minus 3. So when we take x equal to 3, we get 0 by 0 form. So using the identity in the numerator, x power 4 minus 81, that is x square whole square minus 3 square whole square. So a plus b into a minus b. So x square plus 9 into x square minus 9. Again we are changing this as 3 square using the identity a square minus b square, which is a plus b into a minus b. So we get x square plus 9 into x plus 3 into x minus 3. Factorizing 2x square minus 5x minus 3, which is equal to 0. Here the product is 2 into minus 3, which is minus 6. So 1 into minus 6 is minus 6. 1 minus 6 is minus 5. So 2x square minus 6x plus x minus 3, which is equal to 0. So taking common 2x, x minus 3 plus 1 into x minus 3. So 2x plus 1 and x minus 3, which are the factors of the quadratic equation. So I am writing this as limit x square plus 9 x plus 3 into x minus 3 by x minus 3 into 2x plus 1. So cancelling x minus 3 and put x equal to 3. We have 3 square 9, 9 plus 9 18 into 3 plus 3 6 by 3 into 2 6, 6 plus 1 is 7. So we get 108 by 7. 10th question, limit z tends to 1, z power 1 by 3 minus 1 by z power 1 by 6 minus 1. So put z equal to 1, so we get 0 by 0 form. Put z power 1 by 6 as x, then z power 1 by 3, that is 2 by 6, which is equal to x square. So that when z tends to 1 as x tends to 1. Then, so limit z tends to 1, z power 1 by 3 minus 1 by z power 1 by 6 minus 1. We can write this as limit x tends to 1, x square minus 1 by x minus 1. We can write 1 as 1 square, so that we can use the result limit x tends to a, x power n minus a power n by x minus a, which is equal to na to the power of n minus 1. Here n is 2. So 2a is 1. 1 power 2 minus 1 is 1. So we get the value is 2. 12th question. Limit x tends to minus 2, 1 by x plus 1 by 2 by x plus 2. At x equal to minus 2, we get minus half plus half and minus 2 plus 2, 0 by 0. The value of the given function takes the form 0 by 0. So we can change this as limit x tends to minus 2, 2 plus x by 2x by x plus 2. So cancelling this, we get limit x tends to minus 2, 1 by 2x. Put x equal to minus 2, we get 1 by 2 into minus 2, which is equal to minus 1 by 4. Limits of trigonometric functions, theorem 3. Let f and g be two real valued functions with the same domain such that f of x is less than or equal to g of x for all x in the domain for some a, if both limit x tends to a f of x and limit x tends to a g of x exist, then limit x tends to a f of x less than or equal to limit x tends to a g of x. Theorem 4, sandwich theorem, that f, g and h be real functions such that f of x less than or equal to g of x less than or equal to h of x for all x in the common domain For some real number a, if limit extends to a f of x which is equal to L, which is equal to limit extends to a h of x, then limit extends to a g of x which is also equal to L. Let's see the geometrical proof of the following important inequality relating trigonometric functions. Sin x, which lies between cos x and 1, for x lies between 0 and pi by 2. We know that a sine of minus x is minus sin x, cos of minus x is cos x. Hence, it is sufficient to prove the inequality for x lies between 0 and pi by 2. So, in the diagram, O is the center of the unit circle such that angle AOC, which is equal to x radians, and x lies between 0 and pi by 2. Line segments BA and CD are perpendicular to OA. Further, join AC. Then area of triangle OAC less than area of sector OAC less than area of triangle OAB. Half OA into CD, that is area of triangle OAC, which is OA into CD, base into height, half of base into height, which is x by 2 pi. So area of the sector OAC, x by 2 pi into OA square, which is less than half of area of a triangle OAB is base into height, that is OA into AB. That is CD is less than x, OA is less than AB. So from triangle OCD, we have sin x, which is equal to opposite by hypotenuse, that is CD by OA. Since OC equal to OA, so sin x equal to opposite by hypotenuse, which is CD by OC. Since OC equal to OA, we have written CD by OA. Hence, CD equal to OA into sin x, and tan x equal to opposite by adjacent, that is AB by OA. Therefore, AB equal to OA into tan x. Thus, OA into x, which lies between OA into sin x and OA into tan x. Since length OA is positive, we have x lies between sin x and tan x. Since x lies between 0 and pi by 2, sin x is positive, and thus by dividing throughout by sin x, we get 1 x by sin x sin x by cos x, and divide by sin x. It will get cancelled. So x by sin x lies between 1 and 1 by cos x, taking reciprocals throughout, so that we can get sin x by x, which lies between cos x and 1. This leads to an important result. The two important limits, theorem 5, limit extends to 0, sin x by x, which is equal to 1. So the inequality here, cos x less than sin x by sin x less than 1, for x lies between 0 and pi by. It says that the function sin x by x is sandwiched between the function cos x and the constant function which takes values 1. So which is an important result. Limit extends to 0, sin x by x, which is equal to 1. Then the second result is limit extends to 0, 1 minus cos x by x, which is equal to 0. Since limit extends to 0, cos x equal to 1, 1 minus cos x is 2 sin square x by 2 by x, limit x tends to 0, which is equal to limit x tends to 0 sin x by 2 by x by 2 into sin x by 2. So sin square x by 2 is sin x by 2 into sin x by 2, and this 2 comes into denominator. So sin x by 2 by x by 2 into sin x by 2. Just now we have seen the result, like limit x tends to 0, sin x by x is 1. So we are writing this as 1 into limit x tends to 0 sin x by 2, which is equal to 1 into 0, put x equal to 0, so we get sin 0 is 0. So 1 into 0, which is equal to 0. Therefore, the result limit x tends to 0, 1 minus cos x by x, which is equal to 0. Exercise 13.1, 13th question. Evaluate the given limit. Limit x tends to 0 sin ax by bx. So putting x equal to 0, we get 0 by 0. At x equal to 0, the value is of the form 0 by 0. Now limit x tends to 0 sin ax by bx, which is equal to limit x tends to 0 sin ax by ax into ax by bx, multiplying and dividing by ax, so that we can form sin ax by ax to get the result sin x by x, which is equal to 1. Here we can cancel x and x. So this will become limit x tends to 0 sin ax by ax into a by b. Since this is equal to 1, we get a by b. 14th one, evaluate the given limit. Limit x tends to 0 sin ax by sin bx, ab not equal to 0. At x equal to 0, the value of the function takes the form 0 by 0. We can write this as limit x tends to 0 sin ax by ax into ax. Multiply the numerator by ax and the denominator by ax, and multiplying the denominator by bx and divide by bx, so that we can form the result like limit x tends to 0 sin ax by ax by sin bx by bx, which is equal to limit x tends to 0. We can cancel x, sin ax by ax into a by limit x tends to 0 sin bx by bx into b. As x tends to 0, ax tends to 0. As x tends to 0, bx tends to 0. So we get a by b into 1, which is a by b. 17th question, limit x tends to 0 cos 2x minus 1 by cos x minus 1. At x equal to 0, we get the value as 0 by 0. So we are writing this limit as limit x tends to 0. Cos 2x is 1 minus 2 sin square x minus 1 by cos x is 1 minus 2 sin square x by 2 minus 1. So half angle formula, then which is equal to limit x tends to 0. This will get cancelled, 2 will get cancelled. Negative sign will also get cancelled. Then we are writing this as limit x tends to 0 sin square x. So multiply and divide by x square in the numerator, and in the denominator sin square x by 2, multiply and divide by x by 2 whole square in the denominator, so that we can get, so this will become x square by 4, so that we can cancel this x square. So 4 in the numerator, then limit x tends to 0 sin x by x square whole square, sin x by x whole square by limit x tends to 0 Sin x by 2 by x by 2 whole square. So this is 1. Using the result, limit extends to 0, sin x by x equal to 1. So 4 into 1, which is 4. Thank you, children.